Okay, I'm showing you how to simplify square roots. So we're simplifying square roots or radicals. So the key is here you're looking for all the perfect squares, and by perfect square I mean really nice, neat numbers. So for example, a perfect square would be 2 times 2 equals 4, so I know that the square root of 4 equals 2. Okay? 3 times 3 equals 9, so the square root of 9 equals 3, and so on and so forth. The square root of 2 is not a perfect square because there is no perfect nice, neat number that's going to, you can multiply by itself to get 2. It's actually going to be irrational. It's going to be between 1 and 2, like 1.14, blah, blah, blah. Okay, so we're not looking for that. If we find that, we leave it alone. So I'm going to use the example 4 times the square root of 320, or 4 root 320. And I'm simplifying it, just kind of like when we break it down for greatest common factor, least common multiple. That's sort of what we're doing here. So we're doing kind of a factor tree in a way. So we're taking, it's 4 times this quantity. So 4 times, let's break this up, and I'm going to break it up into 40 times 8. Because I know 4 times 8 is 32, and I just add a 0 on here, so 40 times 8 is 320. Neither one are perfect squares. In other words, there's no number times itself that's going to give me 40 that isn't a decimal, and nor is there a number times itself that's going to give me 8. But their factors may have perfect squares in them. For example, right here, 4 times 10, right? So this could be the square root of 4, don't forget to bring down this number, times the square root of 10, and then I'm going to break up 8, so I'm going to take 8 and I'm going to say, okay, 8 is the square root of 4 times the square root of 2. So that makes sense. So 4 times 2 is 8, 4 times 10 is 40, and then we have to bring this 4 down because we're going to multiply all of them together, and they should always give us this. We're just simplifying it. So in this case, I see a perfect square. I know 2 times 2 is 4, so I'm going to eliminate this, which is my whole goal, and make it 2. Bring down my 4. Don't forget that. 10, I know is 5 and 2. So I can say, we'll break that down to the square root of 5 times the square root of 2. And then we have 4 here, and I know that the square root of 4 is 2. And then we have times, bring this down, the square root of 2. Okay, anytime you have duplicates, you can get rid of them and then just make them the number, the radicand, the number underneath. Because if you think about it, square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So it's always going to be this number. And then we have times 2, bring this down, times the square root of 5, times 2, times 4. Now we're just going to multiply like terms, and so we're going to end up with 4 times 2 is 8, times 2 is 16, and 16 times 2 is 32. And then we're just left with root 5. Root 5, you can't break it down anymore. There are no perfect squares in root 5. All right, so that's one way you could have done it. Another example would be, let's say, 3 root 50. I'm going to break this down. Well, I know 25 times 2 is 50, so I could take 3 times the square root of 25 times the square root of 2, because that makes up the square root of 50. I already know 25 times 5 times 5 is 25, so I know this is 5 times the square root of 2 times 3. So this is no longer under the square root sign. This is 5. So 3 times 5 is 15 root 2. Final answer.